Hello, everyone, and thank you for attending today's webinar, A Hitchhiker's Guide to Deploying Hyperledger Fabric on Kubernetes. My name is Emily, and I'm a member of the team here at the Linux Foundation working on the Hyperledger project. Before we begin, I want to cover a few housekeeping items. First, this webinar is being recorded, so if you need to drop off at any point, we will automatically send you a link to the recording via email within a day or two. At the bottom of your audience console are widgets that control all the movable and resizable content windows. You can click and drag the lower right-hand corner of each widget to change the size, and you can move the windows around to customize the layout to your preference. Starting with the icon on the left, the film reel controls the audio for this event, or it allows you to fast forward or rewind if you're watching this on demand. The Q&A widget allows you to submit questions at any time during the presentation. We will try our best to answer as many of them as we can. If you're watching this on demand, you can still submit questions and we can respond via email. The chart icon controls the slide viewing window. The document widget contains links to resources mentioned in today's presentation and other resources we think you might find interesting. You will also have instant access to a copy of today's slide deck. The person icon opens a window where you can learn more about today's guest speakers, and the clipboard allows you to access our survey widget, which helps us collect valuable feedback. Please take a moment at the end of the presentation to answer a few questions about today's session. And finally, the question mark opens a help topic window in case you experience issues with the console. If you're joining us on a non-Ubuntu Linux machine, please keep in mind you may experience lags in slide advancement, and refreshing your browser might help. You can join us on Twitter using the hashtag LFWebinar, and don't forget to follow us at @Hyperledger and @Linux Foundation. As I mentioned, keep an eye out for an email from us in the next day or so with a link to today's recording. That takes care of our housekeeping info. I'm pleased to introduce today's guest speakers, Sasha Grabovetsky and Nicola Paoli. Sasha is CTO and data scientist at Aid Technology, and Nicola is lead blockchain engineer also with Aid Tech. Please don't forget to read the detailed bios of our speakers on your screen, as their work histories and experience are absolutely fascinating. Thank you so much for joining us today, Sasha and Nicola.
Thank you. Cool. So I think we can probably start with a few poll questions as our attendees are coming in. So one of the first questions is that we'd like to ask our audience is, what blockchain frameworks have you worked with? So we'll leave that on the screen for you guys to answer. And actually, we can maybe tell you what we have actually worked on. What have you worked on, Nicola?
I've been working a bit on Ethereum. Of course, I explored Bitcoin, and also mainly I was focusing my work on Hyperledger, so Hyperledger Fabric mainly, and Composer as a tool, and also Hyperledger Sawtooth. I had a quick look on that, and Iroha as well. And what about you?
Yeah, myself, I've been mostly working on Hyperledger Fabric, again with Composer also. I dabbled a little bit in Ethereum at one point, and took a little bit of a look at Sawtooth and Iroha, but haven't worked with them directly. And I haven't actually worked with either Quorum, Corda, or Bitcoin itself yet. So maybe we can see the results we have now. Okay, about 85% of us have been working with Fabric, which is expected given the topic. And about half of you have also been working with Ethereum. Nice. Great to know. Okay, let's go to the next question. We're going to ask you, if you are deploying Hyperledger Fabric, how do you do it in production? In this case, we have a kind of multiple choice because you might use multiple methods. I know we do. So we want to know essentially how you deploy Hyperledger Fabric. Do you do it on bare metal, virtual machines, on Kubernetes, or do you use like a tool like Hyperledger Cello? Or if you don't, we would also like to know that. So, Nicola, what do you typically use when you're developing?
Yeah, mostly from when I started, because there were lots of examples, and that I started using virtual machines mainly, so I could be able to deploy different examples or projects in different virtual machines, and then Kubernetes. So those are the main for me.
Yeah.
What about you?
Yeah, so I also started to work with virtual machines, and then I after working with them for a while and seeing how complicated it is to try and deploy a lot of things with the tooling that was available, I switched to Docker containers and Kubernetes, and I haven't really looked back. I haven't yet worked with used bare metal, and I don't really plan to. But I am, and I think we are looking to at some point contribute to Hyperledger Cello and see if we can include our Helm charts there. Yeah. Let's see what the results of the poll say now. Okay, cool. So about 50% are using virtual machines, and 35% of you are already using Kubernetes, and a few are also using Cello, and quite a lot of people also using bare metal machines. Boom, that's really interesting. Cool. So again to the Hitchhikers Guide to Deploying Hyperledger Fabric on Kubernetes. So we are Nicola and Sasha. Nicola, why don't you introduce yourself?
Yes. Hello, everyone. I'm Nicola, and I'm the lead blockchain engineer at ATech. And I'm working on building business blockchain applications using tools from the Hyperledger projects. And I've submitted improvements and contributions to the Hyperledger Composer, mainly, such as an API key security feature. And what about you, Sasha?
So I'm Sasha. I'm CTO at ATech. I've been working mostly on ensuring that our blockchain solutions can be easily deployed using Kubernetes and Helm. And back in my past life, I used to be a cognitive neuroscientist.
Okay, so we can introduce the webinar. We will split this webinar into 4 sections. First, we will describe the blockchain framework Hyperledger Fabric. Then we will give an introduction to Kubernetes, which is a platform for deploying microservices. In the third and main section, we will walk through a step-by-step deployment of the Fabric CA, the Orderer and peers using Helm Charts, such as the upcoming Helm Charts talks, courses, and how it is possible to contribute to the ecosystem.
So, by the certificate authority, an ordering service using Kafka, and several peers connected to each other through a channel. So let's get started.
Yes. So first, we will run through Hyperledger Fabric and explain why it's awesome and generally over 9,000.
Cool. Hyperledger Fabric is a blockchain framework, and it's different from Bitcoin or Ethereum in that it is permissioned. So each network cannot be freely joined, but must be part of a consortium of organizations.
Yes, Hyperledger Fabric requires 3 types of node: a certificate authority, an ordering service, and a peer. So we will describe each in turn.
So the certificate authority manages the identities. In a nutshell, it registers these identities, which are saved to its database, and then it issues enrollment certificates, which allow the identity holder to demonstrate that they belong to an organization. Finally, the certificate authority can renew a certificate, making an expired one valid, or it can revoke an existing certificate, making it invalid. The ordering service consists of one or more orderer nodes that talk to each other. In development, you typically use a single orderer using sole consensus, which is effectively no consensus. In production, you should really use a proper consensus algorithm, like, for example, Kafka, which depends on an Apache Kafka cluster to exchange messages between the orderers and ensure crash-tolerant consensus on transactions. And finally, peers are the nodes that actually maintain the ledger and communicate with the client applications. Often, we will attach a CouchDB database to hold the world state in a way that we can query it effectively.
Okay. And let's chat now about Kubernetes, which helps realize the possibility of the cloud.
So Kubernetes is basically a platform to orchestrate the deployment and management of Linux containers, which are typically built with Docker.
To work with the Kubernetes system, we should understand the three key concepts. The Kubernetes cluster, hosting the microservices, the chart packages that define the app, and the Helm service that allows us to install charts.
So the Kubernetes cluster itself works with a set of abstractions that allows to group, deploy, scale, and connect containers and ensure they stay running by doing health checks and so-called self-healing, which essentially means redeploying components that have stopped working. All of these can be called orchestration, just like a director that ensures all the musicians. The next concept is charts. Charts are bundles of templates that define and group Kubernetes components into a neat package. They effectively act as cookie cutters for Kubernetes applications. You can browse these guys at the KubeApps Hub. Finally, the Helm is this client-side tool that allows you to package, search, and deploy charts. On the server side, it communicates with Kubernetes using Tiller, which manages the deployment.
Okay, so before replicating what we do on this webinar, we will need the three things. One is a running Kubernetes cluster, then a cheap or free domain name to connect to your cluster, and download the repository. So you can get a managed cluster, a Kubernetes cluster from most cloud providers, especially given their generous free credits.
Once you have a cluster, you will want to install an ingress controller. In this case, we use Nginx. And you will also install a certificate manager, which will renew the TLS certificates to access your subdomains by using a service called Let's Encrypt.
Okay, so we come to the main section. We are ready to start working through the deployment of Hyperledger Fabric on Kubernetes.
Again, let's remind ourselves what our end result will be. First, we will deploy a Fabric certificate authority serviced by a PostgreSQL database for managing identities. Then we will deploy an ordering service of several Fabric orderer nodes communicating and establishing consensus over an Apache Kafka cluster. Finally, we will deploy several peers and connect them with a channel, bind them to CouchDB databases to manage the world state as well.
So let's start with the certificate authority and get to certificates.
Let's do it.
This is probably the most involved process out of the whole deployment. And we will go over the process of registration and then enrollment on a basic level. The first thing you will need is the PostgreSQL server that will support the Fabric CA. Installing it is quite easy. You just need to make sure it has a database called Fabric CA, and this chart is the main stable sub-repository.
Cool. So here are the actual values file that we use for deploying the PostgreSQL server chart. We start by defining what PostgreSQL image version we want to use. In this case, it's 9.6.2. We also auto-generate a strong password using the chart, and we specify that it has a database called Fabric CA. We also add a persistent volume. Here, in this example, we are using the Managed Premium Azure Storage class, which is basically a solid-state drive. Depending on your cluster, whether you're using Azure or AWS or Google Cloud Platform, you will probably be using a different value. Finally, you can see an anti-affinity defined. This does not do much when we have a single instance, but if you are deploying multiple databases, you will probably want them to end up on different Kubernetes machines to decrease the chance that if a single machine fails, that it would kill all your databases.
Yes, so the next step installs the actual Fabric CA chart that Sasha and I created. The pod will take a few minutes to get started, so be patient. We can run the command kubectl get pods to get the actual pod running the CA, and then run kubectl logs to check if the CA server has started running.
The values file for the CA is considerably more involved. Firstly, we define the image tag, where we use Fabric 1.2. We also implement an ingress. This is basically a way for you to access the certificate authority from outside the Kubernetes cluster. In this case, I'm using a test domain that we own to enable access to our CA. We again implement persistence to store the certificates permanently, so we don't lose them if the pod restarts. We also specify a name for our certificate authority, which in this case is CA, and also add the name of the PostgreSQL chart so that our CA chart knows how to connect to the database. Then we define some configuration, such as the Hyperledger tools version we use, which customizes one of the config maps in the chart. And a config map is basically a set of values that you store. It's essentially a Kubernetes abstraction that stores some values that are made available to the pod to read. Importantly, we also specify the certificate signing request and an affiliation list, which in this case is empty. And finally, we again add a pod affinity. In this case, we make sure that our Fabric CA server gets deployed to the same Kubernetes machine as our PostgreSQL server. Once our CA is running, we will need to enroll the identity of the Fabric CA itself. For the first command, we use kubectl exec to check if a certificate exists in the Fabric CA membership service provider folder. If it does not, we will run the Fabric CA client enroll command inside the CA, pointing to the ingress of the CA. Then we can run kubectl get ingress on our own machine to obtain the ingress connected to the Fabric CA service. So this will essentially be the domain name that we spoke about. Once you have that set up, you should be able to use the curl command to get the CA info. Bear in mind that this depends on the certificate manager setting up the TLS correctly, so you might need to wait for a little while before this works. Now that your CA is installed and set up, you can get the certificate of the CA server onto your own machine by using the Fabric CA client binary. If you're using Mac, you can, for example, use Homebrew to install it. We have actually open sourced a public repository to do this. Then you can use kubectl exec to execute the register command inside the Fabric CA to register the organization we will use to host the orderers and the peers. Once we have registered the identity, we can use the Fabric CA client again and actually enroll the identity and get our private key and our certificate. We'll copy the certificate from signed certs also into the admin certs folder, since this identity is the admin.
Okay, here the key thing to notice is that when speaking with the CA, we need to specify the Let's Encrypt authority certificate for the TLS connection, since the Fabric CA client will check that this certificate corresponds to the one it sees when connecting to the CA server.
Exactly.
So since our apps will use the certificate and the key, we need to use a kubectl create secret generic to add this file to the Kubernetes service as secrets.
Before we go to the next section, let's actually look at the config.tx YAML file, which defines the structure of our Fabric consortium, organizations, and the channels. Here we specify two profiles, one for the Orderer Genesis block and one for a Fabric channel called My Channel. Here we define our organization, which we will call 8tech. It has the ID 8tech MSP. MSP standing for member. And this we enrolled our organization admin in the previous slides. It also defines two peers as anchor peers, and we specify them using the Kubernetes DNS, as we will speak to them inside the cluster only and not expose them to the internet in this case. So here you can see that one of these peers has the DNS peer1 HLF peer.blockchain.svc, which means service.cluster.local. And we point to the port 7051 of that peer. Then we also define the orderers in the organization using a very similar format as before. We also define all of the Kafka options. Importantly, rather than defining all of the different Kafka nodes that we will have, in our case we will have 4 Kafka nodes, instead of that we specify the Kubernetes Kafka service as a single address, since that will act as a load balancer to load balance the request to all the different Kafka pods. And this avoids reconfiguration if we decide to scale our Kafka cluster up or down.
Okay. So having defined the config.tx YAML file, we can run the config.tx gen tool that we use it twice. Pointing it to the two profiles, we define it to produce a Genesis block for the orderers and the channel transactions for the peers. So we again have these two Kubernetes secrets to store them on our cluster.
And again, these secrets, they will act very much like the config maps that we defined before. They will act as essentially abstractions that will hold values, but they will actually encrypt them at the same time and hold them in a secure manner.
Okay, so now that we have a functioning Fabric CA, we can get to the orderer and get that consensus running.
So rather than Chuck Norris consensus, we have the next best thing, Kafka consensus, which is crash tolerant. We will need to follow 3 steps to get all of this running.
Yeah. Firstly, we need to install the Kafka cluster itself, which is made easy with the incubator chart available. Note that you need some very specific configuration to make this work correctly.
So firstly, we need to ensure that we have at least 4 replicas of Kafka in order to make it properly crash tolerant. This means that your Kubernetes cluster must be composed of at least 4 machines. We also specify, again, the image and the tag that we want to use. In this case, we use the Confluence Inc. CP Kafka image and the tag 4.112. And we also add role-based access control to our Kubernetes cluster. Again, we have anti-affinities to make sure that the Kafka pods actually end up on different Kubernetes machines. Because if you actually keep if you don't do this, several of your Kafka pods could end up on one machine, and then one single machine crashing could actually get your network down. And here is the most important part. the configuration override section contains several options that are necessary to work with Fabric. I stress that all of these options are necessary, but the most important one is the last one, called log.retention.ms, which specifies that we never want to forget a record, because by default, Kafka will forget records after typically around 2 weeks. I've seen many messages on the Rocket chat of Hyperledger from people who forgot to implement this, and boy, it's not pretty.
Okay, then we can install one of the actual orderers. If you want to install Orderer 2, just change the initial export to set the num and the environmental variable num to 2. Again, we use a chart developed by Sasha and myself at ATech.
So these values file will look very familiar by now. The important things to note are the CA address, which is the domain name of the CA with which we enroll the order, and the CA username of the order itself, which in this case is ord1. We also auto-generate a one-time password to register with the CA, which we will look at very soon. Then we define some configuration to specify what version of the Fabric CA client we install on the order. In this case, we also install the Fabric CA client version 1.2.0. We also specify the type of consensus, which in our case is Kafka, and the ID of the organization membership service provider, which in our case is ATech MSP. Finally, we specify a set of secrets that we will need to correctly connect to the certificate authority, such as the CA server TLS secret, this Genesis block secret, which in this case is called HLF-Genesis, and the admin certificate for the organization. Finally, we can set up the orderer identity. To do this, we first get the CA password from the orderer's secret. This is exactly the password that was auto-generated by the chart. It's a one-time password that we will use for enrolling. We then use the kubectl exec to connect to the Fabric CA and register the identity of the orderer with a CA specifying this environmental variable. The orderer chart is configured to periodically try to enroll with the Fabric CA. Once it does this successfully, the orderer will actually start. We can then get the orderer pod using kubectl get pods and check that the orderer has started by running kubectl logs and filtering for the string complete initialization.
And that's it. You have a basic ordering service using Kafka running. So let's see how to deploy the Fabric peer, which maintains the blockchain ledger. Installing the Fabric peer involves 5 steps, but most of these will look very familiar by now. The first step is to install the CouchDB database. And this is very similar to installing the PostgreSQL chart. So after deploying it, we again use the Kubernetes logs to check if it is running.
The values file in this case is really simple. And it mainly specifies the version of the Hyperledger CouchDB Docker image, which in this case is 0.4.10. We also again specify a persistence so that the CouchDB database holds the data, and an anti-affinity so that CouchDB pods are actually deployed on different Kubernetes machines.
Then we install our Hyperledger Fabric peer chart.
So this values file looks very similar to the order values, since it mentions the Fabric CA address and the peer username on the certificate authority. It also specifies that we are using CouchDB and the name of the CouchDB Helm deployment. Again, we note the secrets that we need, such as the CA-TLS secret, which we need to communicate securely with the CA, the channel secret, specifying the channel transaction that will allow the peer to create and join channels, and the organization admin certificate and key, which is also necessary to actually join the channel, to essentially ask permission to the network. Again, to set up the peer identity, we get the CA password, which is again a one-time password generated automatically by the chart, and we register the peer with a certificate authority, just like we did with the order. We just specify a different ID type. In this case, we specify a peer. Again, the peer will periodically try to enroll with the CA until it succeeds. Once it does, you will see the string starting peer in the logs.
So once the first peer is created, you can create the channel. For this, you will need to specify the address of an orderer, the name of the channel, and the location of the channel transaction that we loaded into the peer from the secret it lives in.
Once the channel is created, you will need to fetch it and join it on every peer that you create by running the peer channel fetch config command inside the peer, and then run the peer channel join inside each peer container as well. Once all of that is done, you can run peer channel list to check that the peer has indeed joined the channel.
And that's basically it. We will now spend a few minutes chatting about the things that we are doing in the future that might interest you. First, Sasha and I created a chapter on the Hyperledger Composer on EDX, which you might want to read if you'd like to learn to create a proof of concept using it.
And I also have created a course on Pact and Udemy called Hyperledger for Blockchain Application, which discusses in more depth both Fabric and Composer.
Yes, and we will also be giving several presentations at the Hyperledger Global Forum in December, where we will go into considerably more depth into the deployment and also discuss a real proof of concept running in Tanzania using these Helm Charts.
And finally, we are also releasing a chart for Hyperledger Composer, and that's being reviewed right now, so it might take a few weeks. But also over the last few days, I've been playing around with Hyperledger Explorer, so if all goes well, we will also create a chart for that as well. Just to, I guess, remind you that Hyperledger is quite a large ecosystem of many, many different projects. In this webinar, we mostly covered Hyperledger Fabric, but there's also a Helm chart for installing Barrow. If you'd like to contribute to the deployment of Indy, Iroha, or Sawtooth, this would be awesome. Maybe you want to deploy your own chart to deploy nodes for these other frameworks.
Yes, and also remember that there are other tools. We've mentioned Explorer and Composer, but there is a Quilt for ledger interoperability, Caliper for benchmarking, and Cello for deploying blockchain frameworks easily.
Cool, and I think now is the time for questions. We went slightly faster than we expected, but if you have any doubts or any questions, we're happy to go back. Okay, cool. So we have so far 21 questions. I think
we can...
Let's start with the first one. So what is the best way to contribute to the existing charts? Basically, the best way to do that is to use the official Helm Charts repository. Basically, you can submit pull requests if you want to, for example, change a chart. For example, you might want to expand one of our charts. For example, a typical update that you might want to do is our current Fabric CA chart. It actually only supports the PostgreSQL database, but you might want to expand it to be able to work with MySQL or some other database. You can create a pull request and we will review it as soon as possible. Typically, we're quite quick to review and we're very, very happy for contributions. Okay, let's see what the next question is. So when customizing a deployment, what should one keep in mind? So let's for customizing deployment, one of the things that we should keep in mind is of making sure that of what are the things that you want to customize. We've actually, in the way that we develop the Helm Charts, we took this into account by creating self-contained Helm Charts that each deploy a specific separate component, such as a single peer, a single order, a single certificate authority, rather than trying to create a chart that tries to deploy a whole network. This, we believe, will make it easier to make customization because you can simply change your config.txt file to specify that you have more orderers or that you have different anchor peers, and simply deploy in a very, very similar fashion as what we've had in this webinar, but using your own specifics. Can I use Minikube to deploy this? This is the next question we'd like to answer. Technically, you can. The thing to bear in mind is that, for one, you will need to change the type of storage that you use. You'll probably need to specify that you're using local storage. And importantly, you will also probably need to get rid in the values files of the affinities and anti-affinities, because you will have a single node, essentially, a single Kubernetes node. You will not be able to deploy it on a separate node because you have a single one. So you'll need to remove these sections. So maybe I can show you one of them right now, one of these examples. So you'll probably want to get rid of where are they? Custodians. So for example, you might want to get rid of that whole section from lines 10 to 16 for this one, because you have a single node. Bear in mind that I haven't actually used Minikube to deploy it. I've typically used the real cluster because I think that is closer to being in production. So I prefer to do that. Okay. The next question is, what is the link to the Udemy course? That's a very good question. Nicola will check it out. Basically, if you search for Udemy and then blockchain for, Hyperledger for blockchain applications, you will find it. And I think that we can probably include it after the webinar. We can add the link to it on the actual repository so that it's easy to find. Basically, and the link is actually quite easy. It's basically udemy.com/hyperledger-for-blockchain-applications. Okay. Where do we need to place our first network folder and balance transfer app in Kubernetes? You don't, actually. So you don't need the first network folder. The build your own first network folder is specifically meant to be a development tool to get familiar with how to deploy Hyperledger Fabric. In the case of Kubernetes, you will need to actually specify the separate components using values files as we have in the repository and as we showed here. And you will need to specify, like write your own config.txt file or adapt it, and then use these two things basically to deploy your network. Will this talk include any integration deployment with Hyperledger Cello or just Kubernetes on its own? So for now, we haven't ourselves yet used Cello. We are in close contact with the Cello developers, and one of our plans is to actually help integrate the charts that we developed into the Cello project to make it even easier to deploy the applications. Okay, what is the difference between Docker Stack Deploy and Kubernetes? I haven't actually used Docker Stack Deploy. Perhaps what you mean is, I'm not sure if what you mean is for Docker Swarm. We haven't used the strongest orchestrator in terms of community and development, so we've only used that to deploy. In production, it is suggested to use, as the next question is, in production, it is suggested to use Hyperledger Fabric. It's supposed to use Kafka-based ordering. But to run it, we need Kafka brokers, and to run Kafka, we need Zookeeper nodes. To support 2 orderers, we need 4 Zookeepers. So now in order to avoid single point of failure, we need to have all these nodes in different machines. How does it affect the overall performance of Fabric? So I'm just going to push this to this line. So actually, you don't need to have 4 Zookeepers. That's the first thing. You need either 3, 5, or 7. Typically, we use 3. Because we use the Kafka chart, you do need 4 Kafka nodes to ensure some basic crash tolerance. The more the merrier, of course. 5 or 6 will give you more crash tolerance, but you'll need 3 or potentially 5 Zookeepers. And all of these nodes need to be on different machines. And of course, that means that they need to have anti-affinities assigned to them on the Kafka value, sorry, on the Kubernetes values files. And of course, this will affect the performance of Fabric. You ideally will want to have a sufficient number of nodes so that things are distributed, but not so many. Like you don't want to have hundreds of machines, which will make the consensus slow down. The next question is, when can I get the Helm Chart repository? So actually, our Helm Charts are all published on open source repositories. One of these repositories is the official Helm/Charts repository, maintained by the Helm Foundation, which is closely affiliated with Kubernetes. And we also publish the same charts on our own open source repository on 8technology /AT-charts. And we can also, what we will do is we will also add information about this on the repository that we shared, so that you can easily find these charts. Can 2 Fabric be installed on different Kubernetes clusters communicating with each other? How to keep the communication of the clusters private if they are in different clouds? So these are 2 different questions. I'll try to answer them in turn. So yes, in principle, Fabric is indeed made so that you can have the nodes communicating between different machines. Right now, the charts don't have, for the peers and orders, they don't have ingresses. This is one of the next things that we want to update them with in order to allow communication from there. This should be quite easy to implement. In order to keep the communication of the clusters private, it will be important to actually implement TLS certificates so that all the communication between the the two clusters is encrypted. And this is a more advanced topic. Okay. Is CA available or supported in Fabric 1.0? Yes, so the certificate authority is supported in Fabric 1.0. All you need to do, basically, is you can actually specify your, let me just find the location. So where is the chart? I'm just going to make this a bit bigger, maybe, to preview. So I think this is the slide, right? Custodians. So basically, no, not that one here. So basically, all you need to do is to change the image tag to 1.0.0. You might actually need to specify a slightly different tag. You will need to check on the Docker Hub because you might need to specify the architecture of the machine as well. But that's basically all you need. That will essentially select a different Docker container when you're running the chart to deploy to Kubernetes, and that's all. Yes. So the next question is kubectl exec dash and etc. Yes, this is the MSP organization admin. That's indeed true. Yes. Okay. Push the slide. Does the CA also support organization and user creation and authentication? And if yes, how do you achieve it? So the CA, we already demonstrated actually how the CA supports the organization enrollment. So we did that in one of the slides before. Let me just see if the preview. We did it right here. So it's related to the previous question. And you can also use the CA also for user creation and authentication. So basically, you can also enroll a client or a user. This is a bit more of a more advanced kind of Fabric CA topic. And it's essentially the best thing to do is to go into the Fabric samples repository, which has a very, very detailed example of how the Fabric CA works. As I mentioned at the start of the presentation, we will only go on a kind of quite surface level over the Fabric CA, but this definitely is possible, yes. Okay, so this is the multi-host environment. This is again, so in a sense, Kubernetes is a multi-host environment in the sense that you're actually running it on multiple machines. If you want to have a multi-Kubernetes or multi-cluster deployment, then we need to actually update the charts, as we mentioned, to have an ingress so that you can communicate with them from outside the Kubernetes cluster. Okay. Have you done any production deployments using Composer? If yes, how was the performance as compared to native Hyperledger Fabric? We've done a number of kind of proof of concept deployments with using Composer, and the performance was decent. It's of course you cannot yet handle thousands of transactions, but we haven't yet formally compared it to native Hyperledger Fabric. So next question is, we have a few organizations, A and B. How do you deploy Docker, Order, and Kafka in a few organizations? As far as I'm aware, you can only deploy an order with a single organization, especially if you're using Kafka, because of the actual nodes, they need to be, in order for the ordering service to work well, you need all the orders to be more or less co-located with the Kafka cluster in close proximity. Don't take my word for it, but from what I read in the Fabric documentation, you cannot yet deploy orders in a multi-organization. You can deploy peers in multi-organization, but not the orderers. Kubernetes admin. If something will get admin private key for Kubernetes cluster, or one, this person can crash the whole organization network. So here's again the case where the whole point of the Fabric CA is to enable you to revoke certificates, which will basically disable specific private keys. So if someone loses your private key because it's a permissioned framework, you can actually disable that private key by revoking the certificate, right? And typically, what you will do is you will not actually deploy only a single CA, but you'll actually deploy a root CA, and then create intermediate CAs that are children of the root CA. This is how we have done it in production ourselves. And if one of those CAs that is intermediate is compromised, you can basically just shut it down and create a new intermediate CA that will take over. Okay, it is very much required, but it is part of the Kafka chart. We haven't shown it in the values file because the values file for Kafka is very, very long, but it actually is possible to either auto-create a Zookeeper ensemble, or to use a separate Zookeeper ensemble that you might have created in a separate chart. Okay, this is again one of the multiple Kafka cluster questions. We've already answered that before. What is the minimum number of nodes required in Fabric development and in production use? So the very minimum number of nodes that is kind of required to actually have a cluster is 2. This is what we demonstrated here. We demonstrated like the simplest possible production-ish deployment with 2 orderers and 2 peers. Typically, you will have more. Typically, you will have at least 3, in most cases 5, 7, 10. Especially if you want good crash tolerance. Any chance we could get access to that chart on Composer? Yes, very much so. Actually, it is already open source. It is actually undergoing review on the open source Helm/chart repository. So you can actually see that pull request. And if you want, you can actually clone our repository of our charts and download the chart for yourself. Potentially install, just download it and install it from your local computer onto your own Kubernetes cluster. Or you can send it to a chart museum that you own, and you can deploy it that way. So it's already available basically, but it's just not been accepted yet to the core master branch of the Helm Charts. And it's also available on our own repository at Charts, which we'll again mention in our repository once we finish. Could you achieve the same results using Docker Swarm? Yes, you could, but we're not going to work with it because for one, Docker Swarm, I think it's being retired. And for two, we're happy with Kubernetes. Okay, this is answered. Slide there. Okay. If we change data on the CouchDB using Fortran tool, data got changed. What in the production sound does the same? So the CouchDB is meant to act as actually a world state database. It doesn't maintain the ledger itself. The ledger is actually maintained on disk on the peers only. So actually changing something in CouchDB will not change the blockchain. What will happen instead is that one of your peers, the one that got its data changed on CouchDB, is going to go out of sync with the other peers, and you will essentially see a lack of consensus, and then you'll need to kind of go and look at how to solve that, potentially killing the peer that was affected and restarting it. Is there a production system with these settings anywhere? So actually in the repository that we're sharing, we are sharing these settings. Most of the settings should be we are using them essentially in proof of concepts in production. We're using quite similar settings, except that we use a root CA and several intermediate CAs. Other than that, our deployments actually look very similar. So we meant these to be essentially a production-ready system. Okay. What are the best online resources to learn creating decentralized apps using Hyperledger? So I think the edX course that has been done by the Linux Foundation is very good. As we mentioned, we have a Composer chapter there. I also have a course on Udemy Unpacked, which we'll share again. We'll mention it on the repository. And I think, and the Linux Foundation also, they have other courses that they run that are also, I'm sure, very good. When should we use Cello and when should we use Kubernetes? They're not actually mutually exclusive. Cello is able to deploy using, it can have an Ansible deployer and a Kubernetes deployer. So the guys are actually working on Kubernetes deployer, and this is why we've been chatting, because the Helm charts that we use might make it easier for Cello to deploy these components. So they're actually not mutually exclusive. Okay. The next question is having the peer database inside the container a risk to lose it? How to cope with that risk? So actually the database, the actual blockchain is not inside the container. It's actually on a disk. So the container itself is ephemeral. And if it dies, it gets restarted. Essentially, you deploy a new container, but the actual data is on a hard disk somewhere, potentially on the cloud if you're using a managed Kubernetes service, or on your own computers if you're using a bare metal Kubernetes. So this is why you use persistent volume claims to store the data, so that when you restart the container, you don't lose data. Okay, I'm not going to just. How do you handle chain code generated? How do you handle chain code generated by peers, which is not known to Kubernetes, since it is generated by peer container, not generated through KT's master? So in terms of the chain code, you have several options. Either you use something like Hyperledger Composer in order to create business network archives that you can install in your peers, or you use the native Fabric systems. And if you're using native Fabric, you typically will need to sign the chain code to actually demonstrate that this is valid chain code that you are able to deploy onto your cluster. If this chain code is not signed, you will not actually be able to deploy it. This is answered.
And I think we have just time for one more question.
Okay. Do you have a working use case for autoscale the Fabric nodes and automatically add peers to the channels? No. And the reason is you cannot, in order to, we don't actually have an autoscale. This is something that if you're interested in developing, it would be quite cool. I think this is a really good idea. But there is no such system as far as I know. I think that's basically my answer. We have a lot of questions, but if you want to, if any of your questions went unanswered, please feel free to contact us. We will be very happy to answer more questions and to chat with you. If you want to collaborate or if you have questions, yeah, we're very happy.
Yeah.
Thank you, Emily.
Thank you very much.
Thank you so much, Sasha and Nicola, for this great session on Hyperledger Fabric and Kubernetes. That's all we have time for today. Thank you all so much for joining us today, and we hope to see you next time on a future webinar. Thank you so much.
Thank you.
Thank you.